Hey, Mark. Great to see you. And today we have Anders Christensson on with us, who's from the Swedish Defense Forces and spent a lot of time working on NATO command and control. So, why are we here today? What are we going to talk about? Well, a lot of times folks want to go beyond Boyd. They want to take apart Boyd. We want to make sure that it's not a stagnant thing, right? John Boyd didn't give us something that just is, hey, this is a dogma. You got to follow it. So we want guests to come on and kind of challenge Boyd, and we have that today with Anders. So Anders, welcome to the show. How are you doing today, sir?
Great, absolutely. Glad to be with you
Great.
from Stockholm, Sweden.
Yeah, and thank you so much for being here. So right before we went live today, we were talking about did you call it the OODA loop? Is that correct?
Right. The
Yeah.
dynamic OODA loop,
Okay.
which essentially fuses in that you have to be aware of that your decisions will alter the outer system and the inner system. And outer and inner system comes from the terminology from Herbert Simon, Nobel Prize winner. Often we call the outer system the operational area, and the inner system is our command and control system. Now, our professor Bernd Bremer, now deceased, has made a theory based on Boyd, but expanded it upwards. By that I mean he uses Jens Rasmussen's design logic or design hierarchies, because as Herbert Simon says, this is design logic when you're going to design a command and control system. So here, by the design hierarchy, Jens Rasmussen states, okay, what's the purpose of command and control? What is the design criteria? What is the functions? What is the processes, and what form is it that are designed to accomplish the processes that are executed in the functions that the functions has to meet when it comes to the design hierarchy to meet the purpose. So that means that 5 steps going downwards and as well upwards.
Okay.
And Boyd emphasizes the processes, the human processes in his what Chet and the other guy, Chet and Chuck,
Yep.
mentioned about the but essentially it's a process. He states he's not dwelling so much into the abstract functions. What is orientation? What is decision? What is in a mathematical term? That is lacking on what Boyd has. You know that Mika Ensley also, which is a psychologist,
yes,
has focused on form, layer 5, and how that accomplish in processes. But you have to move up to set the criteria what the OODA loop has to accomplish.
All right.
And there you have to have observability of the external system, the outer system, and you have to meet steerability with the inner system.
Right.
And that harmonizes with Ashby.
Yes.
And Weik and so on.
Absolutely.
So if you want to calculate with it, you have to go from layer 1, purpose, layer 2, design hierarchy, a design criteria on the functions, then you can observe the processes that are going on in the staff.
And when you mean staff, you're talking about the organization, correct?
Yes, the
Okay.
organization and operational level, from strategy to operational level,
Right.
and further down.
And as you say in your paper with that you wrote with Dr. Bremer, I mean, this is all human centered. This is all centered on the human, and the human is the one that makes the command and control function. And the
Absolutely,
system
humans do click in from processes and form, because in form, layer 5, you choose people, you organize them in a certain way, you add up technology, you add up methods, and so on. All those artifacts that you actually can do. And they are combined in the processes.
Yeah. Well, you say, I love this line from your paper. It should not be designed in such a way that the people will have to help the command control system solve its problems, as if a lot of the problems that wind up coming from these systems, that's what becomes the function of the system, is to solve all its problems, and it's not centered on, people, ideas, things in that order, as Boyd would say.
You have to have help from the layer 1, 2, 3 to support the processes, so humans know, okay, we're doing good now in our command and control, or we're doing lousy. You have to have the ability to see, now we're not coping with the right stuff.
Right. Hey, Anders, I want to bring up something on command and control. Not everybody, it's kind of a four-letter word out here in the US right now that command and control is bad in organizations. Our understanding of command and control is all living organisms, living systems need some type of command and control. It's just, when you look at complexity theory, you need some type of command and control. Now, John Boyd talked about leadership and appreciation. Can you walk us through what you mean by command and control and a command and control system, so you can help our listeners ease into that?
Okay. In a command and control systems, it consists of people, how they are organized, what type of tools they have, what training they have, and if they are working together. And that you can observe. You can always observe processes. You can see that, okay, this group is actually producing sufficient information that has to go into next in the line of organization. You can actually see that. Now, if you want to make some sort of test or experiment, I urge to visit Bloom's taxonomy. Bloom's taxonomy is stating what stages do you have to go through if you're learning. So there you have to know the terms, the relationships, and you have to have the ability to do analysis and synthesize and then value. These are things that you can observe that the learner is doing. You can actually see, okay, he has met the criteria, because if we can do that, the Bologna process would be obsolete.
Right.
Because 46 countries is using Bloom's taxonomy for learning. That's the commonator between all university and technology, the educational system in 46 countries. So in US. Mm-hmm. So we can use that to actually see, is the staff actually learning? Now, that's the process. Now, when it comes to level 1, to direct and come up with a plan that we can execute. Command is feed forward. Control is feed backwards.
Yeah.
So it's essentially focusing the processes and level 5. But they are omitting level 1, 2, 3.
Yeah.
Which you have to have. It's mathematical criterias that are demanding the processes to do right.
Anders, there's so much we could pull out of this conversation. Number one, when John Boyd was looking at the Toyota production system, he saw that control was outside and bottom up. It was from the outside, from the customer. When we think about that, do you concur with that line of thought?
Absolutely.
Yeah. And then you brought up many names, and I just want to highlight those here, and I may miss a couple. You brought up Ashby. You brought up Carl Weick. You brought up Micah Ensley. I'm going to just touch on these real fast. Requisite variety, we've talked about that on the show, how critical that is, and how that connects to John Boyd's OODA loop. With Micah's work, and you may be talking about different work that I'm very familiar with, but that's the different levels of situational awareness, which is very important, and we can make that connection to Boyd's work. And then there's Carl Weick, who we talk about quite a bit on the show, and that is in the world of
Sensemaking stuff.
Sensemaking, yeah. So we have Sensemaking with Carl Weick, and we have Sensemaking with Dave Snowden. He's going to pound me for forgetting his name there. But Carl Weick's work is going back to what I want to highlight here is you can observe things. And that's what he did. He went out and observed how these organizations operate at the edge of the envelope. And instead of creating a case-based approach, he looked at these things and said, hey, this is how this works in these high-risk environments, such as the flight deck of an aircraft carrier, nuclear power plants, submarines, aviation, things like that. So where I'm going with this is everything I'm hearing from you is authentic, right? And that's why this is an important conversation. I haven't heard anything that isn't inauthentic and isn't saying that Boyd's work is invalid. What I'm hearing from you is it's good, but Boyd gave us a gift, right? He gave us something and said, take this and run with it and make it better, right? Do you agree with that?
Yes.
Okay, right. And that's how I think we agree on that 100%.
Yes.
Mark, do you have anything to add on the what we heard so far?
Well, I mean that's what our podcast is dedicated to, is the development and advancement of Boyd's theories, because even his if you've read the Franzo Singa books, Science, Strategy, and War, the very last line is that this is intentionally left open for exactly what you're talking about, for us to continue to build and use it not as religious dogma, which Boyd would reject himself, to do exactly what we're doing, to talk about it. And that was one of the things when I was reading your work that jumped off the page. You're talking about something that's absolutely human-centered, and that the systems and the technology support the decision-making that the humans, a staff, a commander, those are human beings that have cognitive biases, they have learning, they have other things.
Absolutely.
Just one thing I would ask a clarification point. When you say DOODA, like dynamic, observe, orient, decide, act, am I hearing you correctly to say that our process of OODA, our orientation that cycles through OODA, has to be dynamic and not static? Because dynamic wouldn't...
Absolutely, because both the outer system and our inner system, I mean, the troops will be tired when they have done something. They have to reload, they have to rest, they have to do, and so the state variables in the inner system and the outer system is altering because of our decision, because of actions. Ammunition has to go back and reinforced and so on.
And what you allude to in the abstract of your paper, a command post for complex operations that you wrote with Professor Bramer, when you say that line, it should not be designed in such a way that the people will have to help the command and control system solve its problems. The dynamic OODA, if you keep your orientation dynamic, you're avoiding that. You're trying to avoid that. So what you're saying in that sentence of the system solving its problems, that's the static orientation. That's the static OODA loop.
Yeah, the static. When it comes to decision making and the process of science of that, Bremer came through that, saw that originally we see decisions as a decision, and then it takes a long time before next decision has to be done. But in military operations, this is much faster. So that's why he says, okay, we have to have a dynamic. So that states demands on the staff to have a better notion of what is going on, both in the operational area, but as well as our own troops, our inner system.
Andrew, what are the dangers of knowing too much? And let me give you some context. We learned about the 1,000-mile screwdriver from the idea that a general who can watch a predator feed can do something from his office in Ramstein, Germany, or here in the U.S. Is how much is too much visibility?
Too much is when you're blurring or confusing, because all the information is not leading to your end state. It's your end state that is defining what is this strategic objectives and how are we going to meet those strategic objectives. All other information that is not supporting this is obsolete and confusing.
That's the focus and direction, right? That's the Schwerpunkt, as Boyd would say.
Absolutely, absolutely. So you need to source down, okay, what we have this situation today in our outer system, in our operational area. Is this what we want to have? Can we describe the future demanded situation that we strive for?
Right.
How would you describe that? And you describe it as if you were there.
Right.
So
Andrews, I'm going to throw a couple things at you on the OE, the operational environment, the external environment. Some things we're learning from complexity theory. Some things we learned from effects-based operations too. So I want to expand on this because this is critical to what we highlight on the show. From complexity theory, when we look at the operating environment, the external environment, we look at where we are, right? We want to understand that through situational awareness. Where are we now? And we look at the evolutionary potential of the present to modify the future, because we can't define a future, high definition destination, a SMART goal or anything like that in a complex environment because it's complex. So we can run multiple probes, go through the OODA loop, probe, get that feedback from the environment, and move in a direction rather than go to a destination. And this is something that we've been talking a lot about on the show. And I want to bring up effects. You may be familiar with effects-based operations from many years ago.
Absolutely.
That was something that we were trained on, and fighter pilots, and military members, they learn how to start with the end state in mind and work backwards. Well, in a lot of situations, dropping a GBU 12 or 16 or a GBU 28 on a target, that's kind of a complicated thing. It's a known thing. I know where the target is more than likely. I can work backwards. I can find out the time I need to launch from the carrier. I can look at all the threats in the environment and adapt to them. But that's the effects-based operations. I can put an effect on something that I know.
Right.
The problem with this type of thinking is when you bring that back into and say, hey, this is how it works in the military. Well, it works. It has bounded applicability. That type of thinking works in a complicated environment. And I'm using complicated from Dave Snowden's Cynefin framework. It doesn't necessarily work in the complex environment. So this is a shift in thinking for leaders in the military and all leaders is, hey, we can't take these one-size-fits-all approaches to, I'll use command and control, and apply it to the complex environment. So if I'm hearing you correctly, the way we look at the external environment and the decisions we make, those decisions are going to change the external environment, or we have to update our internal environment, which is our orientation, right?
Right.
To always adapt. So I
Yes.
think we have. Do we have alignment on that? Is that what we were
Well,
talking about as well?
Sinofin, if you look at his model of simple, complicated, complex, and chaotic system, we can add the atomic quantum system in the middle, but since that is for atoms, relativity and Schrödinger, his equations, we leave that out. Now, if you look at the structure on a system, it's stable over time when it comes to simple system and complicated system. I mean, a submarine is a complicated system, but it's stable. If you go to the other side, you have quick dynamic altering systems, structures. The structure is altering. If you see on a flock or a swarm or whatever, they are altering in structures forever. And also when it comes to chaotic system, they will smoothly, not knowing, run over the edge and take another state that is completely different, which is very much sketched by Lauren Cobb's the cusp theory, which is the butterfly phenomena. But all those three systems has to meet Ashby's requisite variety,
Right.
at all levels. And Janir Baryam in US has stated that this has to be met on each decision level, which means that here we start in very abstract terms, but you have to meet the requisite variety. You go down one decision level, and that also has to be met by requisite variety. Now, it's very difficult to calculate complicated systems versus complex systems. But if you, I mean, here I have to do an anecdote. If we were about to rewind the last 15 minutes, we will never end up in the same process flow. So reality is not taking the same path over and over and over again. That is, it's not on the map. So we have to have a notational system that reflects sufficiently your outer system. And that when you come into modeling and simulation, you have agent-based simulation, you have fuzzy sets, you have all those beautiful mathematical tools that you actually can mimic some sort of possibility tunnel over time. So if you're keeping yourself within that capability or the effect tunnel, you can actually simulate your own possibilities as well as your adversaries. I mean, he can't walk to the moon from here and up. He has to have a rocket. He has to have all sorts of beautiful things to move up to. So you're bounded by rules.
Right.
And those rules, yes.
So these are things, these are like counterfactuals. There's things that we can do and things we cannot do. And the enemy and our opponent, or however you want to look at it, is the same thing. And that understanding, if I hear you correctly, if that simulation, that modeling, if you can model that, which is not a landscape like we think about when we drive our cars, but it's a mind, time, space landscape.
Absolutely.
If you can model that, and I think this is really important because we've been doing a lot of work on this lately. This is where leaders need to spend their time in understanding.
Absolutely.
Okay.
Absolutely.
Right.
I mean, Joint Chief Staff said for some months ago, we are in deep problems when it comes to say, okay, if we're going to defend Taiwan, all simulation packages are showing that we're losing. So how are we going to meet this? So essentially what you're saying, we have to study much more time on the possibility space that we can do.
Yeah. So do you need a simulation, or can this be done manually with just like a tabletop exercise?
No, because of the complexity, it's difficult for a human brain to calculate all the processes that individuals are going on and producing in interactions. So you have to have it in some sort of simulation, computer-based simulation. Mm-hmm. And that was actually done during the MNE4 at Virginia. So it came from us. So it was there where we tested it. And that was 2006.
So
and then,
is there a danger with this, though? That's what I'm concerned about. So what I understand about complex systems is we really can't model them. And we get into systems of systems thinking. And I know NPS, Naval Postgraduate School, is looking at these, trying to take $180 million and simulate what's going on around us. If my understanding is correct, and I may be wrong on this, we can't really, the map is not the terrain. We cannot map an external system. Any effort to do that is and you go back to John Boyd, it's going to change the system. What I'm hearing from you is there are people that believe we can map an external or our system. Is that correct?
I believe so. So strongly, because you just need sufficient mimic to the reality, not everything. So when you're and of course you have to be critical. It's you have to live with your adversary all the time. When you're producing a model and then come to counter effect or counter motivated, so that there you have the struggle, which has to be very vivid.
Right. So we talk about mapping. I hate to say using a mapping. You call it a mental model, a map. You can call it a digital twin. This is important to understand the external environment. So we have to take the different perspectives of our human system to understand what's going on the outside.
Right.
The danger I see with that is, and I'm going to use an analogy here. When you look at your phone to see what the weather is outside, and you see that it says it's sunny, but you walk outside and it says it's rainy, right? It's raining.
Mm-hmm.
Which one's right? This one, the reality to me is on the outside, but
reality is always right.
Right. So and that's a danger with it, is we don't want people to get fixated on the simulation. We want them looking outside too. Okay.
It's a tool.
Okay.
It's a tool. Modeling and simulation, gaming and evolving is tools.
And you did use the word sufficient. It suffices. It doesn't have to be precise or it's as Boyd would draw out the OODA loop. He would say this is an illustrative abstraction. It's not a precise measure.
Right.
So let me ask you this, because I see this when people explain and describe OODA loop, or I see this even with command and control systems. People are so hell bent on identifying exact precision to that reality that they would back to. Yeah, you can't. So they would go to Ponch's example to say, well, the weather said this, but it's doing it outside. Now I'm completely confused and I'm derailed. What you're saying is, if I hear you correctly, and correct me if I'm wrong, what you're saying is models and maps and systems have to be sufficient enough that empower the human cognition, and we learn as we go, that we continue to adapt and develop.
Absolutely.
Is that correct?
Absolutely. I mean, if you're looking at the phone on it's sunny outside, when you come out it's raining, but one thing is that the temperature is almost nice. So there you have one system state that you can rely on. It's just to allude what your example. Don't take me on that, so to say.
So, Anders, you've been working with a lot of NATO folks over the last many years, and I want to ask what's preventing them from understanding? And I'm not saying we understand this completely, but we're all students of this. I'm talking about our discussion we had up to this point. What's preventing leaders to understand this type of thinking? How do we look at the external environment?
I would say it's coming down to the words command and control. Command is stating your will. I want to see this done. And control is downwards up. And they have to meet. So NATO folks are either talking about command or they are talking about control, not in the same that they have to meet each other. Right. So the induction, the intel guys has to be better to describe in notations that you can actually simulate your operational environment. So the commanders can, what if I have this target or this goal? What happens then? And between these two, when they meet, they source out or they calculate or they visualize the possibility space. So again, you have to be critical. It's many dimensions on this one, the commanding stuff, but it also many dimensions in the information in induction process that the intel has to do. And it's lucky that we now can see that artificial intelligence is actually extracting text to causal loop diagrams, where you can see enforcing or balancing loops within the environment.
And this goes back to an earlier point that it's our command and control system is observable, right? We can see so with that, and we talk about this a lot. We say that teamwork is observable, therefore I can measure it, but I got to know what teamwork actually looks like. And the same may be true in what are you looking for? Where, with artificial intelligence within a command and control system, what can be fleshed out of that system and be usable by AI? And then I want to go back to the Cynefin framework too, which is, hey, that complex world where we can only understand things in retrospect may not be a good place to put, I may be wrong on this, put artificial intelligence. That may be a space where we want humans to operate, because humans have, going back to flocking and things like that, the dynamic systems, humans are pretty good at detecting weak signals, right?
Absolutely.
Okay. So is this the same approach that you're trying to take with
Absolutely.
this?
Again, modeling and simulation, AI, and all that beautiful tools, they are artifacts. And you can always reason or contradict what you are stating. And you have to have a vivid discussion in the staff, so they actually can pinpoint down and highlight those weak signals. Often there are devils in the detail is the weak signals. I would say.
And at no point are you ever in your proposition, you never violate that order that Boyd says: people, ideas, things. It always goes in that order. Ideas and things serve people.
Well, for when it comes to behavioral science, I'm not fighting those guys because they are thinking right. Because they have studied people and they have seen that there are things that there are coming good things out of it. But you have to frame those guys with the purpose, design criteria, which is observability and steerability, or as Celiac says, reachability. You have to have the ability to reach your state. Otherwise, you won't be able to do anything. You have to sufficiently reach your state.
And you can't do that by looking inward alone. And in Boyd admonished in organic design organic design for command and control, he said that any command control system that forces its adherents to look inward is going to disintegrate. It's going to become unglued. What you're suggesting is you have to look out both ways. Yeah,
both ways. It's a Janus head. Janus looks in and out. You can actually, if you take the classical OODA loop or the OODA loop, the observe, orient, decision, and act, and make a control circuit of it, you can actually build a transfer function from your steering to the response. And if you look at that equation, you'll see that and you try that, what happens if the under the line is 0? What happens? Then you can explain all sorts of what happens in the outer world and your system because of its 0.
Yeah. Anders, I'm hearing this from you. My expectations of this conversation were to look at Boyd and kind of rip it apart. In his work anyway. What I'm hearing from you is the opposite, and that is there is value in what John Boyd provided to us. Plenty of value.
But on the process and form, level 4 and 5.
Mm-hmm. Okay.
And they are framed by the level 1, 2, and 3.
Okay. And I'll have to go through that model again. Level 1, just remind the audience, mainly
purpose. Okay. You produce a direction and how to reach that direction. Mm-hmm. That's the purpose of command and control. Now, the design criteria, is that you have to have it. You have to have the external system, the outer system, observability.
Mm-hmm. Yes.
You have sufficient state vectors, tensors or whatever, variables that are actually mimicking what's going on outside there. Mm-hmm. And as Ashby says, the steering, the inner system, has to meet those criteria, those variables. So you actually can manipulate towards an end state. And number 3, the functions, the abstract functions of data collection, presented for orientation, mm-hmm. where you actually pick out which are the essential states for our mission.
Right.
Then you go further and say, okay, how should I do this?
Yes.
That's the planning.
Yep. That's a counterfactual or plan. Yes.
Right.
Yeah. So I'm what I'm hearing from you is we're learning a lot about the same things from the neuroscience community. The free energy principle, we talked about that on the show. Everything you walk through just is the same thing we're hearing from them. In my opinion, I may be off on this.
Okay.
But the observation is that sensing capability. It's sending that new information that is surprising, because our brains want to minimize surprise. We don't want all the information coming into us.
Mm-hmm.
We always want the difference between what we expect and what's actually coming in.
Mm-hmm.
The counterfactuals, or that planning, or that prediction, that's an internal
Mm-hmm.
thing to the internal system that's making a prediction about, let's do this and run it through our system to see what happens before we act on it, right? So that's a simulation, right? And this might be related to Gary Klein's work too with RPD, recognition prime decision. Okay, so there's and I love this conversation. There's so many things we're pulling from, and we have to apologize to our listeners because there is so many references in this, and this is kind of like a synthesis of what we've been talking about. You hit on so many things today. From quantum physics to biology and anthropology.
Yeah.
So this has been awesome.
It's why that command and control is the science of command and control is cybernetics. That's the host area, I would say. It's cybernetics.
And as we start to, and this is important for us, is as we start to, we're generalists, right? We're not specialists by any means, but we're bringing all this together on this podcast to go, hey, look, when you're talking about artificial intelligence, go look at how different modalities of prayer or meditation or even psychedelic assisted therapies help you mitigate your past experiences, right? That trauma, that PTSD, and all that. There's a connection there. Or take a look at the connection between those things and agility in an organization and resilience in an organization. And that's why
agility,
this is so.
For me, agility is that you actually have a quick turnaround in your dynamic decision. You see weak signals in the outer system, and you source out and try to, what are we going to meet this with? That's an agile system for me.
Yeah. So you have tempo and time there, or speed, right? You have how are we observing the external environment, and how fast can we respond to something we see in it, right? And I think is that kind of aligned to what you said about agility?
Right.
And I like that line of thinking. It's not when we're probing in a complex environment, we're running multiple safe to fail tests or probes, if you will, to find out where we get repeatability, so we can amplify it or dampen it, right? So we want to move faster. And that's what we're trying to do with improving an OODA loop in a complex domain.
Absolutely.
Okay. Yeah, this is great. I love this. And I'm sorry for losing our. Go ahead.
You have to be aware of that you can outmaneuver. You have a higher pace around all this than the adversary. And now we're getting the tool AI, which is shrinking the time of modeling tremendously. So you actually can pinpoint down faster what is the sufficient reachability and how am I going to meet this?
Here's another question. What happens to organizations, leaders that don't embrace this type of thinking? What's going to happen?
I think they will be outmaneuvered. They are going to ask, what's happening? They are not doing the action. Guys that are actually in for this fast pace, they are dominating the environment. But the other guys that are not with you, they are going constantly asking, what's going on? What's going on? Fill me in.
So there, when you say fast pace, it's not merely fast on its own. It's at a faster pace, deliberate action with continuous learning and adaptation.
Absolutely. Absolutely.
Yeah, that's a perfect word for it.
I mean, if you're faster than the adversary, you win.
Yeah, with higher quality.
Yes. Of course, of course.
All right. Anders, this has been an absolutely fascinating conversation. I just want to thank you for your time today. Love to have you back on the show. I mean, like, again, I want to set the stage for everybody. Or I thought we were going to attack John Boyd here, but I think we all agree there's value in it, and we can continue the work by taking a look around and what's happening with advances in technology, lessons from biology, complexity theory, and making that OODA loop better, and
Absolutely,
not just
absolutely.
Okay. Yeah, Mark, do you have any last minute thoughts for Anders today?
No, I think that Anders has said multiple times, absolutely. I mean, this is absolutely why we have our business, and this is absolutely why we have this podcast. It's building and developing and advancing these ideas because it was left open intentionally with a tremendous foundation to go in different directions. As Ponch, you used the term generalist. This pulls from every angle, and I think that the imperative thing for those that are listening is that your systems that you have to command and control your sports team, your company, whatever it is, if they're only looking inward, your competitors are out there. They're going to identify that quickly, and they're going to be able to strike and outmaneuver you, as you say. Mm-hmm.
Well, we want to thank Anders for being on our show today. Thanks for taking time in your late afternoon to be with us. Again, we want to have you back on the show maybe middle of next year to look back and see where we are with AI, because I think that's going to be a bigger thing.
Absolutely.
But I do want to turn it over to you, Anders. Is there anything you want our listeners to know about your work, what you're doing, and how they contact you?
Well, you have my email, and we're working on two things. And that is, the first one is Visplan, which is the command stuff. And I am working to use AI to actually reach sufficient reachability. So they can work together, these two, and define some sort of possibility space that you can maneuver in. If you want to read about the possibility space, I urge you to read Gibson. He is a fine guy that explains the psychology for this.
And that's Affordances, correct?
Yes, right.
Yeah, and that's we're doing a lot of mind time space mapping with Affordances, so I love it. This is great. Yeah. All right, Anders. Hey, thank you so much for being on the show, being on No Way Out. Again, we'll invite you back on middle of next year, and I just want to thank you again.
Please,
Yeah,
absolutely.
thank you, Anders.
It has been